Hi there folks, this is Glenn Rhodes here. Last week I put together a video on YouTube showing some really simple stuff that I had done in Unity with the new the Unity 5 Realtime Illumination, or Realtime Global Illumination, and the physically based shading. And I was surprised. I got a lot of views and a lot of people asking if I could sort of show a tutorial of how I did what I did. So this is basically what it is. We've got this little environment with these straightforward cubes, cube-based things. There's a reflective material on the ground that's got some emissive texture on it. And then we've got this sort of kind of like a television screen type of thing that I was going for anyways, and you can turn it on and off and it illuminates and casts its own light and it updates the global illumination. And we've got this sunrise cycle going, and there's this water plane over here, and yeah, and it's basically, I kind of put it together relatively quickly because I just wanted to see what it would look like. And so here, let's put this thing together. Okay, so the first thing we're going to do is start a new scene. So I go into Unity, File, New Scene. So this is the default Unity 5 scene. It includes a directional light and a camera, and in the lighting it set up for the default skybox, which is a procedural skybox. We're going to be creating our own. So let's get rid of the directional light and get rid of the main camera because we're going to be putting our own in. So first things first, I have this material here. It's basically, to create a material, you go create material, just so you know. Call this skybox. In the inspector, we change the shader to skybox procedural, and these are the settings for the procedural skybox. Now I have figured these out already. So 0.057 is the sun size, atmosphere thickness. Well, we'll set it to 1.25, but there's actually a script that's going to be controlling this, which I'll be showing you shortly. The default sky tint, we have it at 120, 120, 120. The ground color, black. And exposure of 1.56. So these are the numbers that I figured out made the most sense for the scene that I was building. It's going to be different depending on your particular scene. So now we've got that created. Let's drag it over into the skybox setting. Now we have no sunlight, of course, so it's not completely sure what to do with that. I have a prefab already made called Sun, which I'm dragging in, and it is basically just a directional light. The intensity is set to 1, bounce intensity 0.58. Now I've got this script, these two scripts, which control the rising and setting of the sun, which I'll be going over in a bit. So you kind of have to tweak and play with your settings until you find what works. For this particular tutorial, I'm actually not going to be using ambient light reflection in real-time sky reflections, which are automatically applied to objects when you don't have a reflection probe near them. I'm going to disable baked global illumination, set the real-time resolution to 8, because I need the fine detail of the little grid lines where they intersect the wall. Set the directional intensity to 1.57, bounce boost to 4, default, continuous baking, yes. So that's all correct. Okay, so the next thing we need to do is put together the geometry. So I have these cubes already made. They're just basically cubes that have a material on them, which is just a standard shader with sort of this yellow color applied to the albedo of the standard shader. It's really straightforward stuff. So I'm just going to drag these in to the scene. So that was the left wall, so that means that our view is this way. Okay. The front wall, nope, that means our view is this way. Got it. The rear wall. And the right wall. And this pillar over here, which I don't really know what it's for, but I thought it would be cool to have a pillar. I don't know what I was thinking with the scene. It's just basically a floating building in the middle of an ocean. Maybe it's a perfect vacation spot. So left front, rear right pillar. Okay, so that's good. So yeah, so there we go. So the Global Illumination just finished doing its bake while I was chatting. So that's how straightforward it is, and that's how automatic it is. There's nothing, there's nothing special to the Global Illumination. I turn off this because we only want real time for this demo. So let's see here, floors. So we have two floors. There's a metal floor that's on the inside, and then there's this sort of lit grid floor. So these are a little more complicated. So I'm going to drag in the metal floor first. So this is basically, it's got this material. It has an albedo map, which is this sort of sci-fi texture that I have here. It's got a normal map. Again, it's from this texture. Now it is, I set it to minus 0.37, and these are the settings for the metal. We've got an emission map in here, which we don't actually need because it's at 0. So I'm going to take that away. Let's see here. So it's still baking, but right now it's not reflecting anything because we don't have any reflection probes in the scene. So this is the grid floor, which is outside over here. And this again, it's similar to the other floor, but it has, let's see here, these are the settings, same textures, but it's got an emission map. Now an emission map, this is actually just the grid from the projector, which is in the standard assets, just a black and white texture with a grid on it. And I have it set to the emission map. 5.21 is the sort of emission level that I have, and it is set to real-time global illumination. This is important. It goes through and it does all sorts of calculations about how emissive materials would sort of move and propagate light. So there we go. So now it's done calculating, and as you can see, it understands that this area here is emissive, and it's actually emitting light which is bouncing off this wall. So if we move the offset, let's try the Y offset here, the light moves along with it, and it's not recalculating every time. And so when you move the emissive surface, it knows how to approximate, because like here, for example, it's doing a little flash thing, but it approximates what the light is doing. So that's really cool. So if we offset the X, same thing happens. It gets brighter as it gets. So you can do this whole sort of real-time global illumination, moving light kind of effect. So let's go back here. I forgot the ceiling. Let's see, ceiling. Okay, here we go. Now, one of the important things to notice is that all of these cubes, all of these objects, they're all light map static. That's really important because Unity, the lighting engine, will not do any calculations on any object that is not light map static. So you need to make sure, and if that's often one of the biggest culprits when something doesn't seem to be working, check to make sure that it's light map static. Same with the emissive materials as well. They require light map to be light map static so that it knows to calculate what that light is doing. Okay, so the next thing we want to do is place the ocean. So the ocean is just a massive plane that it's just a standard plane set to 200% scale. And the material, the water material itself, is really just a metallic, well, you can see the settings here, with a normal map and a height map. The normal map is just the basic water normal map from the environmental standard assets. The height map is just it's an image that I made. It's just basically noise. And then there's a second normal map, which is the exact same normal map as the previous, set to 0.32 intensity. And let's see here, our tiling is 40 by 40, and the tiling of the second one is 6 by 6. The offset is that, but the offset is being moved at runtime by a script. So that's that. And all this does is it because of the material, it reflects the light of the sun in the sky. So this is the standard for first-person controller, with a few extra things on it that I have put in place. So this now it has a camera to grab from, so it's showing some reflections on the water. Let's see here. So in the first-person controller, I have a reflection probe. Now, this is how we do the floor reflections. Basically, the reflection probe is below the character. So if the base of the character is here, the reflection probe is exactly the height of the camera below. Because technically a reflection, like a real-time reflection in the floor, which is what we're trying to do here, is basically just viewing up through the floor and flipped upside down. That's kind of all a reflection is. In fact, you can see it's kind of doing it there. Now, the reflection probe, we got a culling set to not show the floor. So we've got this metal floor, and we need to change its layer to floor, and the grid to floor. And we need to set the reflection probes on the floor to blend probes. And there, and the reflection probe itself is set to real-time, every frame, all faces at once. This is a pretty expensive process to implement, but it's really the only way to get real-time reflections, because if we don't update it every frame, let's just say that we only on awake refresh it. When we run it, what's going to happen is, see, the reflection just kind of moves instead of showing what you would be seeing from a reflection in your position. So if I update it to every frame, run it, now you can see what it's doing is it's recapturing the reflection every frame from the reflection probe that's beneath the first-person controller, which is technically down underneath the ground. So really what you're seeing, what the reflection probe is seeing, is like a photograph from the ground, from beneath the floor looking up, but we're masking out the floor right here. So the reflection probe does not include the floor, which is which layer this is on. Now, one of the problems that we have is that the water is also taking its reflections from the reflection probe that is on me. But we don't really want that to happen, because what you end up getting is, I don't know if you can tell there, but what it's doing is it's reflecting on the water what my camera is reflecting of the room. So we're getting these weird kind of like highlights over there. So we need a separate reflection probe for the water. So I have this reflection probe here in my prefabs. Basically, it's just a regular reflection probe. Drop it in. It itself is also set to real-time every frame, no time slicing. It's lower resolution 128. And then we need to tell the ocean to use that reflection probe. So we need to override with this and override, so we only use that reflection probe because we don't want it reflecting what we're seeing inside the room. Two more things I need to add to the scene. We've got this TV screen, which is an emissive material. It has an emissive value of 0.01, so that's just enough to tell the Global Illumination baking that it needs to do some calculations, because if we set it to 0, it'll compile this particular material shader without any emission. But we want to be able to modify this emission at runtime. One more thing we need to place in the scene is the stars. The stars are just a particle system that is essentially a large sphere. That's all it is there, doing that, with a radius of 1000, and these are all the settings here. The stars are between 5 and 14 in size. It's just white, anywhere between white and blue randomly. And what they do is that when you first start it, there's up to 1000 at any given time, and they're just randomly placed on this sphere, which just creates the impression of stars. And then this is rotated at runtime with the sun rotator that I'm going to show you in a minute, and that creates the star field outside. So we're getting a few errors down here in the console. We have to hook up a few things to this script that I have here on the sun. Let's see here. First we have to hook up, drag the TV, which is the renderer, the water, the stars, and the reflection probe that the ocean is using. And I'll show you what these do in a minute. Now if I run this, the errors are gone, and I can turn on and off the emissive material on that. The sun is rotating, and it should set properly. Now, how is all this happening? If we have a script that is controlling the keyboard, turning on and off the light, animating the ocean, and rotating the stars. And so this is what we have here. So we have a renderer. We have a reference to a renderer called the light wall, which is the television screen right now. We take a reference to the water, the renderer of the water. Then we get a reference to the stars, which is just the transform for the particle effect. And then a reference to the world probe, which is the reflection probe that is not attached to the player. It's the one that the water is using. So on our update function, we set the rotation of the stars to the rotation of this object, which is attached to the light. So what's happening is that as the light is rotating, which we will see in another script, the stars are set to the same rotation. So every time we hit the T key, we toggle this boolean, light on. And then, now this is where a bit of trickery has to happen, because we need to tell the dynamic global illumination to update itself when the emission changes. So if the light is on, we have a color called final that is basically white, and this is what the TV screen is going to be emitting, is white. Now we have to convert, because we're using HDR, high dynamic range, we have to convert we have to basically convert the intensity. So I want the intensity of 5, but we have to put in this, and it converts it to I don't know the exact number. And then on the material of the light wall, we set the color to this value, and then we have to tell the dynamic GI to set its emissive value of that light wall to the same color. And then that will cause it to propagate to the scene. Because if we don't do this, if I take these two lines out here, so we just set the color alone. It turns on the light. There's a bit of reflection going on, but it's not illuminating. And if we go to nighttime, it's just not lighting up the scene the way you would expect it to. And that's because the global illumination needs to be told to update. And then what we do is we grab the transform of the position of the main camera, which is your eyes, and we set the world probe to that position, because everything with a reflection that's supposed to be real time needs to kind of be based on your perspective of the world. And then we set the main texture offset of the water to time.time divided by 100. And then the second texture offset, which is the, if we go back to the water here, remember that we did a secondary map here. We need the two maps going at the same time to create the water ripple effect. So we just basically move them by time.time. So they're always going to be updating every frame. Okay, so the day-night cycle is basically controlled with this single script, auto intensity. What it does is it has a color gradient that is used to determine what the sun color should be throughout the period of a full cycle of the rotation. So this is when the sun to here is at the highest point, and this is when it's at its lowest point, directly beneath you. We specify the maximum intensity as well, maximum intensity. So this is going to be scaling the intensity value from the highest point down to the lowest point. And then we have this other value here called min point. As the sun cycles from highest to lowest point, so directly above you to directly below you, it goes from +1, crosses the horizon, it's 0, and then it's below you at -1. And I'll show you the code as to how we calculate that. So min point is kind of where we say this is the point where the sun is considered to be gone. We don't actually set it to 0, which would be right at the horizon, because we want the sun to go a little bit below the horizon before we make use of min point, which we will be showing. Max ambient, min ambient, these are the similar concept, but in this case we're not using any ambient light, so we don't really need it, but I have it in the script anyways. Fog color. This is something that's applied to the fog color over time in the exact same way that the day and the night color is. So it helps that, you know, when the sun is setting and rising, which is about here, the fog changes to more of a yellow, but during the day we want more of a sky fog color, and then at night we go for some black, sort of, you know, so it's darkness. The fog density curve, this just shows what do we do to the fog over time. So this again is, so here is kind of midday, so here the fog is much lower, and in this case, in my particular case anyways, I set the fog to higher at night. Fog scale is just a number that we can scale the fog with. Atmosphere thickness. This is, I found that sometimes when the sun went below the horizon, the atmosphere was still red, so I had to scale the atmosphere thickness based on whether it's night or day. And finally, the day rotation speed and the night rotation speed. So this is how fast. I just found that you didn't want to be sitting in the nighttime for as long, so you rotate the night sky faster. So we can technically go like, so let me get there. So it sets, the sun's going to go down, and then it'll pick up speed once it crosses below 0.2 there. So that can make for a short, if you have a game where you already have a night cycle, sometimes you want the night cycle to be faster. Or sometimes you want the day cycle to be faster. It depends on your game. So in my case, I'm going to go -3. Okay, so let's take a look at this script, the auto intensity script. Here we define all of the public variables that we showed you before. We're using the gradient class as a nice way to get a changing color over time, and also a curve for the fog density, which in this case it's the animation curve class. It's cool because Unity does represent all of that in the inspector properly. We have also the vectors, the vector 3s for the day and the night rotation speed. And here we have something called sky speed, which is just a multiplier that I use. So when you see the day kind of speeding up a little bit when I'm waiting for the sun to set, I'm doing that with keys, and I'm just adjusting this value. So then we get a reference to the light that this is attached to. And we grab the sky material from the render settings. Okay, so when it comes to determining what our sun is doing, what our color is doing, where we are in the whole cycle, we end up using a dot product calculation. So first thing I do is I calculate the range, which is kind of how much time the day takes up. So 1 being the top, and then minus the midpoint. So if your midpoint was on the horizon, which would be 0, 1 minus 0, your range would just simply be 1. In my case, I set it to -2, so my range is technically 1 minus -2, which is going to be 1.2. So what we do is we get the dot product between the forward vector of the main light and the standard vector 3 dot down, which ends up returning a value of 1 to -1. 1 is when the sun is at its highest, or when the rotation is pointing straight down. And -1 is when the sun is at its lowest, or when the rotation is pointing straight up. We then take that and we can use it to calculate an intensity with this line right here. And we set the light intensity to that. And then we also do the same thing for the ambient light. Just like we did above, we take the minimum ambient point, we do the dot product, we get an intensity, and we set the end. In my case here, it's 0s and 0s, so ambient light is never used. Using dot, which is now going to be a value between 0 and 1, we can calculate the main light's color, and we set the ambient light to that color as well. In this case, it's not being used, but by using the gradient dot evaluate, what it does is it takes a value between 0 and 1, and it can calculate and return to you an exact color for that point. We do the same thing for the fog, and we can evaluate a point on the fog curve, again in the same way, and we multiply it by fog scale, which is that scalar that I have in there. And then in a similar way that we calculated the light intensity, we calculate thickness of the atmosphere. And then we set that particular value on the shader to that, so that our atmosphere will get thicker and thinner throughout the day. Finally, we rotate our sun. We rotate this particular light, either day rotate speed or night rotate speed, based on the value of dot, which is calculated above. So if it's a positive number, anywhere above 0 to 1, it's going to rotate at day-night speed, or day rotate speed. And technically this is clamped from 0 to 1, so night will always be 0, and day will be anything ranging between 0 and 1. Finally, we just look for the keys Q and E, which are right next to the WSAD keys, and I just use that to speed up and slow down the sun, the rotation speed. A couple of other quick things. In our water plane, we have the mesh renderer set to cast shadows as two-sided, because when the sun drops below the horizon, we want it to stop casting shadows on our scene. So if I turn off shadows, you'll see what happens. So as you can see, it's casting this nice shadow But when the sun goes below the horizon, which is about here, you see it's still continuing to cast shadows because it's technically casting light through the water. So we set that to two-sided so that no matter which side of the plane it's on, it's casting a shadow, which is a kind of a cool new thing they've added to Unity. It's really, really helpful. And then finally, to get that nice sort of glow bloom effect that we get when for example, if you look at the sun, see how it's kind of glowing. And in fact, if we pause it about there, that glow is being caused by the Sonic Ether Natural Bloom and Dirty Lens script, which you can get on the asset store. It's really, really cool. And all it does is it looks for anything that's in the HDR range that's kind of emitting higher than 1, and it blooms that intensity up and creates a nice color light bleed effect. And in fact, it's tied to intensity so well that let's just set the intensity to 0.4. If we go out and we look at the grid here, and we go to the grid material, and we turn its emission up, it really, 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 really glows. And if we turn off the bloom, you can see the difference. It's adding all of that light. And of course, having turned that up, you can see that it changed the emissive light that floor is now casting. And a few more quick things. In order to properly use the Sonic Ether Natural Bloom and Dirty Lens effect, you need to make sure that your main camera is set to HDR. In fact, it gives you this warning if you don't. And you need to make sure that in your player settings, your color space is set to linear. And finally, I'm going to actually turn on the fog. I showed you all the code that touches the fog, but now let's turn it actually on so it does something. So as the sun goes down, you see the fog color on the horizon changes. And that's all. I think that the Global Illumination is really, 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 really powerful. The things that you can do now, just the ability to indirectly affect the light, you're going to end up, being surprised at every turn when you see things that are happening that you don't even realize are happening. Like, for example, let's get the sunlight back. This light is reflecting off the water here, and I was surprised to look up and realize that it was doing that to the ceiling above. It's a whole new way of working with light, and it's just a lot of fun. So that's it for this tutorial, and thanks for watching. If you have any questions, post them below, and please subscribe, and I will be doing more of these over time. Thanks very much for watching.